this section we're going to be talking about solving systems of equations by the graphing method. And we've got a couple of vocabulary words to begin with, and the first one is consistent. A consistent system is a system where there is at least one solution. Now that could be a single solution or it could be infinitely many solutions. Independent systems are systems in which the lines that you're graphing with are unique or different from each other. Now let me draw three different pictures for you. In the first picture, we're going to have two lines that cross at one nice neat point. And that is the ideal situation. This point in the center here is x comma y, and we have one unique xy solution. And this is the way most of your systems are going to result. We're going to have a nice neat equation, a nice neat solution to the system. A second case we're going to be dealing with is where you have two lines that are parallel to each other. And when the two lines are parallel, there is no solution to the system because there is no point in common to both lines. The third case is where the two lines are basically the same line lying on top of each other, and in this case we say there are infinitely many solutions. Now, I want to note along with you that infinitely many solutions is not the same as all real numbers. Because with all real numbers, we're saying our solution is a number. Now that's what we say when we have infinite solutions to a single equation. But for example, this point right here that I'm drawing in for you is not on that line. That line has infinitely many points on it, but this is not one of them. So infinitely many does not mean everything, and we're not dealing with numbers, we're dealing with points. Now, anytime we have a system in which there is one unique solution, we say that that system is consistent and independent. It's consistent because there is a solution. The two lines are independent of each other, meaning the two lines are different from each other. In this second case with parallel lines, we say that the system is inconsistent, meaning there is not a solution to this system, and technically the two lines are independent, but we don't usually say inconsistent and independent. Usually inconsistent is enough. When we have infinitely many solutions, yes, that is a consistent system, because there is at least one solution. There's infinitely many. And in this case, we say the lines are dependent upon each other because they actually are the same line. So these are the different cases we can have when we're dealing with these systems. Now we turn our attention to actually solving our first system graphically. This system is actually rather easy to graph because both of these equations are in slope-intercept form. And if you notice in this first equation we can add a plus 0 to the end if we wished, and we can see that the y-intercept is at 0. And then the slope of 2, or negative 2 over 1, would tell us to go down 2 and over 1 to our second point. And if you want, you can keep going down 2 and over 1, down 2 and over 1. You can kind of back it up if you want to until you can get the location of where that line is. Our second equation is also in slope-intercept form. It has a y-intercept at 1, and this time it has a slope of negative 3, or negative 3 over 1. And we're going to go down 3 and over 1. And we see that these two lines are going to intersect at the point 1 comma negative 2, once we draw these two lines in. Now the system the graph, it really isn't the solution. It's this point of intersection that's the solution. The lines are there, the graph is there as a tool to help us come up with the solution, which is the point which is common to each line. We could take the points 1, -2, x, y, and substitute it in for x and find the resulting y in each of those equations.